In this video, we are going to learn about logic gates. We learn about the number system. Now it is very clear. Binary, octal, hexadecimal, decimal. All these number systems are used for different purposes, right? To represent color. If we write in binary, we need to write a very long sentence. Therefore hexa is introduced, right? But there is a method to convert hexa to binary. So therefore different purposes this number system will be used, but we need to understand clearly. Computer will understand only 1 and 0. Finally everything will be converted to 1 and 0, right? On off signal, digital electronic. Logic gates are used to apply logic, right? In previous video clip under digital electronic I explained to you. For example, if you press a character A, right, the circuit is designed such a way generate on off signals, then it will be fed to one IC, integrated circuit. According to the logic, IC can activate corresponding circuit. Right, now signal is passed to display A. When you press B, signal generated is different from A. Then the IC can activate the circuit to display B, right? So therefore for all these purpose logic gates will be used. Now there are basic 3 types of logic gates: AND, OR and NOT. We need to get very familiar with this. AND gate is similar to series circuit, right? You would have learned in science. Now if you connect a battery here and a bulb here, right, to light the bulb you need to on both these switches, otherwise circuit is not completed. No, this way it is easy to remember, right? So AND gate always both of these need to be 1, then only you will get the output 1, right? 1 means there will be a 5 volt, right? 5 volt, then here only you will get 5 volt. 1 and 1, then only get 1. If 1 and 0 here, 1 and 0, no, can't light. Then 0 and 1, can't. 0 and 0, can't. So this is known as truth table, whatever the output for all possible combination. The another thing you need to remember, depends on the input, will be getting the combinations here. Now for example here only 2 inputs, no, right? So base is 2, we know binary means base is 2. How we calculate the combination? 2 to the power 2. Then there will be here likewise 4 combinations. Let's say we are inserting another input, then there will be 3, no? Then how many combination? 2 to the power 3, then 8, right? This is how we need to check without miss out any input. We should be able to write all the combinations. Then first of all we need to verify how many combinations. 2 to the power 2 means 4, so there has to be 4 combination. The writing method also we will use the sequential order. Sequential means value 0, value 1, likewise, right? So because here only 2 digits we are starting from, the we know the now binary value, right? From left side, first will be place value 1, next will be 2, next will be 4, likewise only going, no? So 2 input mean only the place value is 1 and 2, right? So then now here that is for this purpose only. Here you no need to worry, right? Only 1 1 you get 1. For the combinations, now see I am writing here 0 0 for 0 value, next value is 1, no? Then 0 1, here the place value is 1, here the place value is 2, no? So I wanted to make it 1 after 0 after 1. Then 2 mean here the place value is 1, no? We are making 0 here, we are making here 1, then this is the value for 2. Then for 3 we need to on both. Very simple, right? First you see how many combinations, then you place these values, but always start from, you can start any order, but we will miss out, no? Therefore we need to start from the minimum value. First you write for the 0, then you write for 1, then you write for 2, then you write for 3. If 3 inputs are there, it will go from 0 to 7, right? So this order we need to write it and go. Then we can see the output. So these two need to be 1, so only here you get 1, all other combinations 0, right? This is the AND gate. We need to understand very clearly, yeah? Because in when we are doing circuit, once you understand this basic theory, then it is nothing. You can solve any complicated circuit, right? Now here 3 input is possible, right? Next is, always remember, AND gate is actually product. Product mean, you remember like multiplication, right? A dot B dot C, A dot B, right? Here product, both A and B, A dot B. Even you can write this way also, it is also same. Here A and B, then we AND with C, then again A dot B dot C, right? Then O function. O function is similar to parallel circuit, right? Here you connect a bulb here and the battery here, then either this or this, right? Switch on, this will light, no? So therefore any of this become 1, output will be 1. Again the combination same, 2 input, no? 0 0 0 1 1 0 1 1, but only when 0 and 0 0, all other status output will be 1. And you can write similarly 3 input this way or this way, right? Then this is actually summation, right? Adding. So therefore O gate always add. So now onwards you remember, O gate always use plus, AND gate use dot. Writing is nothing. A, what is the gate? O, then put plus. B, A O B, then O C. Likewise for each and every input you need to place the gate functionality, that's all. If it is an AND gate, then A dot B dot C. So this the basic thing, but we need to practice, because using this basic theory you can handle any complicated circuit, right? So this theory is very very important. Not function is opposite. If you input 0, output will be 1. If you input 1, output will be 0. Now here only 1 input, no? So 2 to the power 1, then 2 to the power 1 is equal to 2. You will be getting only 2 combinations, 0 or 1. Now this circuit is clear, no? Now see, we have placed the battery. Now here the current is passing like this and going. Switch is off, right? When switch is off, this is on. As you connect this, what will happen? Right, you know the basic property of current, no? Current always take smooth pathway, no? Now here there is a resistance, no? So here no resistance, no? So therefore always current willing to pass through this, right? So earlier it is open, therefore it is passing here. Now once you close this, here no resistance, it will quickly pass from here, not go here. Very tiny current will be passing from here, but here only the major current go. Therefore it is off. So therefore it is opposite, clear, right? When on, this is off. When this is off, this is on, right? Now we are going to see the basic, right, how these logic gates are integrated. Now you need to get very familiar, right? So this circuit, not just looking and writing the output, right? You need to understand clearly how these are derived. Then you repeatedly see, you should be able to write all this without any doubt. That is the main reason. There shouldn't be any doubt related to this. Now see here, A, right? You come here A. What is the gate? And very simple. Then A and put a dot. That's all. Right? It's meeting the gate and, so therefore it is product A dot. Then you see the other input from here only you need to start. Here, if you start from here, confused, right? Because we are considering this gate now. Right here, come here, line, right. Input is B. Okay. Once it come here, not is used, right? Not mean opposite, no. So always opposite is here using like bar, right? If B is input, opposite to B means B bar. So that mean always not B is 1. So B is 1 mean here it is 0. If B is 0 mean here it is 1, opposite. So that we indicate using bar. Then A dot is written. Now it's coming to the AND circuit, bar input. Then A dot B bar. This AND circuit is for A dot, what is this? B bar. Now it is clear. Now see here. Here the input is A not. Then A bar. A bar and. Then you put A bar dot. Because A bar, this is an AND gate. What is the next output? B. Then dot B. Up to here should be very clear. Now what is this gate? O gate. O gate is a summation, no? So now the input is this, right? Not one digit, right? Here this is the combination of this signal, no? Now this only we are feeding here. Therefore we need to feed A dot B bar O. What is this gate? O. Then here you need to place O here. Then this one, what is next input? A bar dot B. O A bar dot B. So if you can write this with clear understanding, you can write output for any kind of logic gate, right? We can see later complicated circuit as well. I'll take another example here. A, right. B, right. Then A dot B. A dot B, correct, no? AND gate, right. Then here this output go here. A, not A bar. B, not B, B bar. This is the AND gate, A dot B bar. This is the O gate, no? So what is the input for O gate? It may be one single one or combination, no problem, whatever it is. Here we have derived correctly, then we know this is the input. Then A dot B, this is the O gate. Now how we indicate O gate? With plus sign. O A bar dot B bar, right? Now it should be very clear how AND gate, O gate, NOR gate function. Once it integrated, you should be able to write the correct output here, right? So stay tuned for the next video. Next video will be gradually we are going to see how to derive Boolean expression and how to write complicated truth tables and how to handle solve practical application, all these things. So these things need to be very clear. Thank you.